Hello guys, welcome to my YouTube channel MATHSOLOGIA. In this video, we discuss probability distributions. In probability distributions, the first topic is random variable. Let us understand random variable through example. Consider a random experiment of tossing two coins together. So we take random experiment. Random experiment means an outcome which cannot be predicted with certainty for sure. We cannot say that 100% this is going to happen. That is called random experiment. Or in other words, we can say that random experiment has multiple outcomes. Then the set of all possible outcomes. Then the set of all possible outcomes. We call it as sample space. HH, HT, TH, TT. These are all possible outcomes. So when we toss two coins together, first coin shows head, second coin show head. In the second case, we have first coin head, second coin tail, then tail head, tail tail. So these are called sample space. Set of all possible outcomes is called a sample space. Next, let us define x is equal to number of heads. Here we are defining one function that is denoted by x. X means here number of heads. Now this rule, this is just a rule, number of heads. We apply this rule number of heads to every outcome of the sample space. So here we have totally 4 outcomes. For every outcome we shall apply this rule number of heads. So we get here x of, we can add x of hh. Just count number of heads in this outcome. We have 2 here. Like that. X of ht, 1. Number of heads. X of th. In th there is only one head, so we write 1. X of tt is equal to 0. So because tt means there is no head, therefore x of tt is equal to 0. So here x is equal to 0, 1, 2. The values of the function 0, 1, 2. Here we don't write 1, 1. We don't repeat 1. We write only once because it is called a range. In range, we don't repeat the values. We have to count it only once. X is equal to 0, 1, 2. So by understanding this example, now we can define the random variable. A random variable is a function that assigns a real number to every outcome of a random experiment. Outcome of a random experiment. So mathematically we can write x is a function from sample space to real numbers. Here x is called sample space. Here R is real number, and then we call this X what we defined before as random variable. That is the meaning of random variable. For every outcome of a random experiment, we can assign a real number by defining some function. We call that function as random variable and denoted by X. Here X is called random variable. Here we defined X is equal to number of heads. We can change this into different way also. We can take X is equal to number of tails, or we can define it as X is equal to 0. So let us take another example. X is equal to 0 if first is head, 2 if first is tail. Here we are defining another type of function x. X can take only two values here. X is equal to 0 if first is head. X is equal to 2 if first is tail. Now we can define x of hh. For the same experiment, x of hh. Here first is head, then we write answer 0 here. Next, x of ht. Here also we write 0. X of th. Here we should write 2 because first is tail here in this outcome. Therefore give the number 2 because that is the random variable defined here, condition given. Last one, x of tt. X of tt also 2 because in this first outcome is tail, therefore 2. If head comes first, then we write value 0. If tail comes first, we write value 2. Then x can take here two values, that is 0 comma 2. So though we have 0 0 two times and number 2 is appeared two times, we should write only one time here because this is called range. Range means the set of all possible values of the random variable. So this is all about introduction of random variable. Next, in random variable, we have two types of random variable. In random variable, we have two types. One is discrete random variable. Another one is continuous random variable. Discrete random variable, here if random variable takes integer values, that is like 0, plus 1, minus 1, plus 2, minus 2, etc. Then x is called discrete random variable. I will write here DRV, discrete random variable. Continuous random variable means if random variable takes the values in some interval of the form a comma b. Example 2 comma 3 minus 1 comma 3, like this. So basically in random variable we have two types. One is a discrete random variable, And second one is continuous random variable. Discrete random variable, they are all countable values. 0, 1, -1, +2, -2, 3, -3, like this, countable values. But continuous random variable is, it can have infinite number of values between the interval. So in real life examples means, for discrete random variable, we can give one condition, number of students in a class. So here we should say the count is 50, 60, 35, like this. We cannot say 35.5 students are there in the class. We cannot give in fractions. It is a whole number. And in continuous random variable, we can say height of a person. Example, height of a person, it can be 5.8, 6.6, like this. So here height of the person means it can have fractions also. So that is the difference between discrete random variable, continuous random variable. So first we discuss the topics that comes under discrete random variable. I will take that same example, experiment of tossing two coins together. There we got sample space S is equal to HH, HT, TH, TT. Like this we have got. And we defined random variable x is equal to number of heads. And here we got random values, x is equal to 0, 1, 2, number of heads we got. That is x of HH is equal to 2, x of HT is equal to 1, x of TH is equal to 1, x of TT is equal to 0. So we can write this in the form of table. That will be easy to understand. Here I will write S in sample space outcomes. Here I will write X and use small x here to denote the random values. Here we have HH, HT, TH, TT. Here we have 2, 1, 1, 0. Here total number of outcomes, how much? Total number of outcomes is equal to 4. Our next work is to find the probability of every random value. Now, so what is probability of x is equal to 2? What is the chance? Chance of getting 2 heads when you toss two coins together. Here we have totally 1, 2, 3. There are 4 outcomes. Out of 4 outcomes, 2 appears only once, means one time. So we write 1 by 4. 1 by 4 means it is 0.25. So 0.25 means it is 25%. So 25% chances are there that you get 2 heads when you toss 2 coins together. That's the meaning. Next. P of x is equal to 1. So what is the chance of getting 1 head? Here 1 appears 2 times. So 2 divided by 4. So 1 by 2. 1 by 2 means 0.5. 0.5 means 50%. So 50% chances are there that we get one head. Finally, P of x is equal to 0. Here 0 appears only one time in this table. We can see this. So 1 by 4. 1 by 4 means again 25%. So finding the probability for each random value, getting 2 heads, getting 1 head, getting 0 heads, we get 25%, 50%, and then 25%. Now we shall list all these probabilities in the form of table. List it. Here sample space, the sample space, x random values. Now here I will write P of x. S is here HH, HT, TH and TT. The random values are 2. See here both are combined and we have to write 1 here. Don't write 2 times 2. And here we have 0. So probability of getting 2 heads is, you see the above 25% you got 0.25 probability, right? Here 0.25. Again 1 by 4. 1 by 4. Probability of getting 1 head is 1 by 2. Probability of getting 0 head is 1 divided by 4. Now, here we got one table. The listing of probabilities for of every random value of a random experiment is called discrete probability distribution. Just list out the probabilities for every random value and write in the form of table. We call it as discrete probability distribution. Next we have discrete probability distribution function. This is a very important topic for solving the problems. Discrete probability distribution function. So this condition is very important now. If for each value xi of a discrete random variable x, we assign a real number p of xi, where I is equal to 1, 2, 3, etc. up to n, such that first condition that p of xi is always greater than or equal to 0. Second condition, summation of p of xi is always equal to 1. Then the function p of x is called a probability function. Probability function. For problem solving purposes, these two are very, very important. Probability cannot be negative, it is always positive. And the sum of all the probabilities will be 1 always. Then we say that p of x is called probability distribution function or just probability function. Since we are studying discrete, we can say discrete probability distribution function. We can verify this condition for the previous example also. We shall go back to this previous example. So you can observe same example. Here we could see probability values are 1 by 4, 1 by 2, 1 by 4, right? Here all the values are greater than or equal to 0. We can clearly see that 1 by 4 is greater than 0, 1 by 2 is greater than 0, 1 by 4 is greater than 0. First condition satisfied. So here p of x is greater than or equal to 0. Second condition we shall verify. Summation of p of x means what? Just adding all the probabilities. If you add 1 by 4 plus 1 by 2 plus 1 by 2, definitely answer is, sorry, here 1 by 4. Answer should be 1 here. 1 by 4 plus 1 by 4 is 2 by 4. 2 by 4 means 1 by 2. 1 by 2 plus 1 by 2 is 1. So clearly this is a probability distribution function p of x. If these two conditions are not satisfied, it is not a discrete probability distribution. So some important points here we should know. First point, probability value is always positive. Always. You cannot get negative. And we have probability value always lies between 0 and 1, both inclusive. 0, that is less than or equal to p of x less than or equal to 1. So you never get probability value negative and it cannot be greater than 1. This is the range of the probability. If you get 1.5 at the end as answer for any problem, definitely it is wrong. Probability cannot cross 1 and it cannot be negative. So this important thing we must remember. Next we have mean. mean and variance of discrete probability. So mean is given by and denoted by, we use mu, summation x into p of x. We multiply random values and its probability, corresponding probabilities, and sum it up. We get the mean value, summation of x into p of x. Next we have variance. Variance v is equal to summation x square p of x, use some bracket here, and then minus mu square. This is the way how to calculate variance. Next we have finally standard deviation. SD, it is denoted by sigma. Sigma is the square root of the variance. Standard deviation means square root of the variance. So if the table, after the table is formed, we have x and p of x values. From the table, these three can be identified. These three can be identified. Next we have cumulative distribution. So what is cumulative distribution? For this, consider a discrete probability distribution table. Here I write x, here I write p of x. X means random values. I will denote it by x1, x2, x3, x4. And for probability values, write p1, p2, p3, p4. From the table, how to find cumulative distribution? Cumulative means it will be of the form p of x less than x2. Suppose p of x less than x2 means, just mark this value x2 in the table. Less than x2 means we have how many values? X1. We write p of x. P of x1 means p1 is the answer. Suppose if I had p of x less than or equal to x2, again we mark x2 here, and in this case now x2 also included. Less than or equal to means if you have this equal symbol, x2 is included. So we have to write here p of x1 plus p of x2. In the previous case, we wrote only p1 because x2 was not included. But in this case, there is equal sign, means x2 is included. Therefore, we should write p of x1 plus p of x2. If I write p of x greater than or equal to x2, again x2 we have to mark in the table, and then you have to check whether x2 is included or not. X2 is included here because we have here equal sign. So we should start from x2 and continue till we reach x4, because x4 is the last value here. So one more example, p of x less than x4. x4 means mark here x4, just mark x4 and check x4 is included or not. In this case, not included, it is only less than. Therefore, you have to consider all the probabilities which is less than x4, p1 plus p2 plus p3. Don't take p4 because p4 is not included here. Finding probabilities of this type is called cumulative distribution. There can be one more case, probability of x1 less than x less than or equal to x3. This can also happen. So I have to take the values between x1 and x3 and check whether x1 is included or not. In this case, x1 is not included, so we cannot take. But x3 is included, so x3 should be considered. So here we have to take p of x2 plus p of x3. P of x2 means p2, p of x3 means p3. So between, you have to collect the values from the table and just add them. That is called cumulative distribution. So overall summary, I can give whatever we discussed in this video. Random experiment, random variable. So random variable, key points here, random variable. Random variable is denoted by x or y, capital letter set, etc. Like this we can denote random variable. Random variable means what? It is a function from sample space to real numbers. Means for every outcome we can assign a real number with the help of some predefined function. We can find a rule, apply that rule to the given sample space, then output will be real number. Then we call it as a random variable. Next we studied discrete. If discrete means the values will be like this, 0 plus or minus 1 plus or minus 2 plus or minus 3, etc. Next we studied continuous. Continuous random variable means random values will be like this in the form of intervals, minus 2 comma 5. Next we studied distribution function. Distribution means what? Listing of the probabilities in the form of table. And the two important conditions here, probability is always greater than or equal to 0 and sum of all the probabilities is always equal to 1. Also, probability value always lies between 0 and 1. Cannot be negative. P of x is always positive. At the end we studied cumulative distribution. So that's all in this video. In the next video we are going to discuss the problems on discrete probability distribution. Thank you.